So hello everyone. As Claudia said, my name's Olivia and I'm joined by my colleague Matteo, and we both work as consultants in professional services here at Esri UK. So welcome to our session on enhancing maps and apps with simple arcade expressions. So I wanted to start by asking, have you ever wanted to change how your data is displayed without actually changing the underlying data set? Whether that's improving text formatting or calculating new values from existing fields. Or have you ever needed to dynamically calculate relationships between fields in a dataset, or even across multiple datasets? Or have you ever wanted to change how a feature is displayed based on individual attributes or values? Well, these are the exact types of scenarios where a small, well-placed arcade expression can make a significant difference, enabling more dynamic, informative, and effective maps and apps. Rather than being used to build applications, Arcade is designed to enhance configuration within an application by embedding expressions that run in the context of where you're creating them, such as pop-ups, symbology, or a specific widget. So we're going to show this in action today across Map Viewer, ArcGIS Dashboards, and ArcGIS Experience Builder, exploring ways to enhance your visualization and functionality, all whilst keeping your app performance firmly in mind. Now, we won't have time to cover absolutely everything on this slide today, but the examples we will show will be applicable elsewhere. And this is worth noting, because Arcade is executable across many different parts of the ArcGIS system. So do keep this in mind if you or your organization have other apps that could use enhancing. So we decided to base today's session on something that many of you will have already used today, London's rail network. By combining Transport for London's open data for station locations and usage patterns, along with Ordnance Survey's National Geographic Database and points of interest data, we've created two example apps to showcase the power of Arcade. Now, the first is a dashboard showing station usage patterns across 2025. On the left-hand side, we have some summary statistics by network and individual station, and we can understand how stations relate to one another and how the crowding has changed over time. We can understand the typical peak patterns by time of day and day of the week to highlight particular peak patterns in travel and also to understand anomalies driven by specific events. So if I go ahead and search for Greenwich Station, we can see there's a significant spike of around 30,000 people on the final Sunday in April, driven by the station's proximity to the start line of the London Marathon. Now, our second application is a simple Experience Builder app, which is designed to show attractions in London and their nearby stations. So we can filter, explore the attractions on the map, and use the web links to find out more. Now, before we dive straight into the configuration itself, I wanted to touch on the map that sits behind these apps to show you the impact of changing from default settings to using Arcade. Now, the map on the left-hand side largely uses default settings. Compared, we have the same data on the right-hand side, but this has some small targeted enhancements, the most obvious of which is symbology. By applying a bivariate style, we can immediately understand which stations are busiest overall by their size, and those that have seen an increase in usage through their color. Now, as we pan and zoom around the map, you'll also notice differences in labeling. Whilst both maps have labels, they appear at different scales, and the text has been reformatted on the right-hand map to provide more information at a glance. And now let's have a little look at the pop-ups. So the default map has a raw fields list containing all of the station information, and at the bottom we have a related table which contains all of the daily usage figures. Now, whilst we have all of the information we need here, it's difficult to extract any sort of insight at a glance. By comparison, on the right-hand side, we have clear, focused information. We have a summary of the key crowding patterns from the related table, including an interactive chart, and we even have insights derived from data that doesn't directly live within the map. So now I've shown you what's possible. I'll pass over to Matteo to show us how we can start building expressions.
Thanks very much, Liv. So before we get into it, it's probably worth asking, what is Arcade? Arcade is a portable, lightweight, secure expression language available across the ArcGIS system. If you're unfamiliar with scripting, a useful way to think about Arcade is in terms of Excel. Functions like trim, proper, or even having a lookup table follow the same concepts in Arcade with easy syntax. You're just applying them directly within the map viewer, and you have capabilities that deal with geospatial. Arcade is driven by what we call profiles, and we interact with profiles through the builder. And I've got a screenshot of that over here. A profile is a context in which your Arcade expression is executing. It will change slightly depending on where you're executing it. Briefly, we have profile variables. So these are the potential inputs to your expressions. They'll be drawn from your map and your data. We also have function bundles. So there'll be functions that deal with, for example, maths or logic that are available in every single profile. But if we're working with labels, we may not have access to feature set functions, for example. We also have the Arcade assistant. So if you don't know how to get going, you can have a natural language conversation to get an idea of where to start. At the moment, this is in preview in ArcGIS Online. It's available in the map viewer and experience builder, and expected to come to enterprise by the end of the year. So essentially, the builder sets out your rules of engagement, much like VS Code or other development environments might do. Let's take a look at what this looks like in reality. So if I hop over to my map view over here, we've got an unconfigured map that Liv just showed us. And one of the first things I notice is that my labels are a bit messy, especially around the DLR over here. I've got those uppercase labels and that DLR suffix. And I can change that using Arcade, which is really handy, especially if you don't own the data. So under the Settings toolbar on the right-hand side, there's a Label tab. And if I open that and I hit that universal programming icon, I can open up the builder. So let's name this something good, like Clean Labels. And what I want to do here is twofold. I want to remove that suffix, and I want to make a proper case for those labels. And if I open up my menu, I've got those options we just chatted through. So let's take a look at functions. Since I know I'll be working with text, if I don't really know how to get started, there is a text function bundle at the end that I can look through. Equally, I can search for the relevant function, so for example, replace. And if I click into that, I get a little bit more information about the inputs to that function, what the parameters look like, and I can even just pop it into my text editor right where my cursor is. And a really nice feature of Builder in ArcGIS Online is that we have some helpful IntelliSense. So if I select something in my function that I want to edit, I can start typing with a $, and we have some autofill options to access my feature, put another full stop in, and these are the attributes that sit in my data set. So let's go ahead and select name. And that's the same as coming into the profile variables menu, coming into feature, and dropping that in. Same thing. So let's replace this with what I actually want. And what I'm doing is I'm searching for that DLR suffix text. I'm going to replace it with nothing. And that's going to get me half of the way there. What I can then do is replace this and wrap it in another function. And at the same time, I'll get rid of this so that we can see all of it, assign it to a variable. So what I'm doing is wrapping all of that, what we just saw, into a proper function, which gives it the nice casing that I want. And by giving it a name, in this case, I've used camel case, because as you'll notice, Arcade uses capitals at the start of each function, so it's good to differentiate. It makes it easier for me to use that later on in constructing a label. So let's bring in some extra information from our data. In this case, I'm going to pull in some network, so which network my station belongs to. And on line 9, I'm going to construct my label using what's called a template literal. So this is really good practice if you're creating lots of variables and want to put them into an output later on. It's enclosed in these backticks over here. And what it means is that you can write a simple text expression or a string like you normally would. So for example, I've got that \n for a new line. I've got some brackets. If I type in a $, and curly braces, I can then put in the variables I've just created. If we run that really briefly to get a preview, you get a nice sense of what that's going to look like. I think all that's left to do now is actually replace that last line with a bit of logic that's going to help my map's performance and clustering. So I've replaced that with an if statement that just says, only display the label if the map scale is below 75,000. If I hop out of that, you can see we get an immediate feedback from the map, and my labels look much nicer than they did before and are standardized across the map. And really handy, if you zoom out, it looks much cleaner now. So with a little simple expression, we've done a lot of heavy lifting. If you don't know how to get started at all, that's completely fine as well. That's where the Arcade Assistant comes in. And I ran a prompt earlier just before this session, and it's actually given me a pretty good idea about what I could put into my expression. So we've got the right sorts of functions. We've got proper, and we've got replace. It's just used them in the slightly wrong order, so it wouldn't get me to where I needed to be exactly. But it's given me a really good idea about what functions I'm going to put in. And just be mindful when you're using it. There are a few good practices we can make note of. So this is my prompt over here. And what I've done is I've given the exact attribute name that I want to use, so $feature.name, so it knows exactly what to hook into. And I've been really precise in terms of giving it the exact text to look for in that replace function. And I've avoided any superfluous language, so keep it simple for the builder. And make sure to give it a thumbs up, thumbs down if it's good or bad. Helps our feedback. The next thing we can do to get towards that map Liv showed us is to mess with the symbology a little bit. So if I head over to the styles pane, I can do that using the expression option. And I know in my data set there exist two fields, one for expected daily crowding at each of my stations, and one for actual observed crowding. What I want to do with Arcade is bring some insight out of that data without actually editing the underlying schema. So if I name something, something like %diff, know what I'm doing, I'm going to pop in an expression that's not doing too much, but it's going to make a big difference. On lines 2 and 3, I'm pulling in my attributes, so typical actual counts. On line 6, we're calculating a really simple percentage difference. And on line 9, we're going to return that. And if I give that a run, you can see a nice preview of that numeric value. So that's going to drive the symbology. What's really nice to do in situations like this is add a little bit of logic to protect ourselves in case there are errors. So I'm going to pop in a little bit of a fail fast on line 5. What this if statement is doing is saying, if there's no data in any of my attributes, or if that is equal to 0, we're going to skip that. And that defaults on the calculation, which helps for performance and errors down the line. If we were to run lots of other functions or more complex functions, that's going to help with performance as well. So if I hop out of there, I immediately get a sense in brighter colors of which stations are more busy than expected. And you can, of course, still use other parts of your data set to drive other aspects of symbology. So in our example earlier, we've used the actual recorded crowding at each station to drive the size of our points. So with a simple expression, a little bit of tweaking to our symbology, we've immediately narrowed down to the readers of our map their attention on which stations are more busy than expected. Now we can then start to look at our pop-ups. So I'll hide that for a moment. And we have a lot of options under our pop-ups to apply Arcade in two different ways. First of all, attribute expressions. So these return numeric or text fields that you can paste into your text elements down here. We can also return blocks of Arcade, which return dictionaries that store, for example, charts, tables, or rich text. Let's take a look at some attribute expressions first of all. And let's say I want to change the color of my station name, depending on what network it belongs to. It's really easy to do this using just one expression. It's called when. And what I'm doing is I'm just pulling my network data set on line 2. So I'm at network feature. And then the way the when function works is you give it a condition, and then following that condition, if it's true, give it hex code to return. And a really nice new feature of ArcGIS Online is that you can now edit these hex codes intuitively within the map viewer, which is going to save lots of faffing around. So I'll keep that there for now. If I give that a run, you'll notice it gives me a hex code, which is not that much use if you just paste it as plain text. What we can do is come into our text element, select the text that we want to change, and under the text color option, there's a data-driven capability that comes up. So make sure you've named your expressions really well, because it comes in handy later on. If I select my network type color, head out of there, you can see we immediately get a sense of what network that station belongs to. So you're, and once again, focusing that reader's attention really effectively with a simple expression. We can go even further and return a sentence using some Arcade, which is going to help with the user experience later on. And if I open this up, lines 1 to 13 are actually exactly the same as what we've done for our symbology. So we're going to fail fast if we need to, and we're going to calculate a percentage difference. We're just going to add a little bit of simple logic on lines 16 and 17 to say, if that percentage difference is greater than 0, let's return the text busier and nice attention-grabbing emoji, because that's always fun. And on line 23, we're going to put in another template literal, and we're going to use it to construct a sentence really effectively. If I give that a little run to preview, that's what it's going to give me. And in the same way as before, rather than coming into the font color option, we can just paste that as we would a normal attribute in the pop-up text element. Cool. So adding logic like this into our maps can help us to start to add even more complicated but exciting functionality. And Liv showed us earlier that we can have, for example, layers that talk to each other. So if I hop over to my configured layer, over here, you'll notice this bit of Arcade code. And that's what's drawing this nearby information into my pop-up. So that we're not showing people that information in the map, but we're bringing it out anyway, which is really powerful. Let's take a look at what that's doing under the hood. I know this script looks a little bit longer than what we've been looking at, but actually the logic behind it is pretty straightforward. In our experience, it's mostly about knowing the syntax. What we're doing is we're bringing in our data set using a feature set by name function, and that sits within our map. So we just give it its name, the attributes we want to pull in, and make sure we pull in its geometry as well, so what that true argument is doing at the end. Lines 8 to 12, what we're doing is constructing a 200-meter buffer around each of our stations, and then we're going to do an intersect on line 12 to see if any points of interest fall within those buffers. We're then going to initialize an empty array to put our point of interest text into, which is really key later on. But before we do anything else, we're going to fail fast again. So line 20 to 36, we're doing two things. This for statement is saying only populate that array if that point of interest has a name value. And then if no value is found at all, we're going to return some nicely formatted text to say there's no information. What we can then do is use a for loop to iterate through and do a couple of things. So line 45 looks a little bit daunting, or it did to me when I was planning this session. But what we're doing is just starting a counter, labeling it I, starting it as 0. And since we made an array earlier for points of interest, in coding terms, that means to access the first item in an array, it's got a value of 0. So what this bit of the expression here is saying is that if that position in the array is lower than the total count, proceed to wrap that point of interest in a list tag for HTML. So that's how we get those bullet points later on. This I++ notation just says we're going to do that sequentially, so we're going to go from item 0 to 1 to 2, so forth, until we got no more points of interest. And on line 52, we're just constructing some HTML to basically pad around it. So we've got some URL tags to basically wrap those lists. And line 64, we're returning that using a dictionary. And that's how we got that really nice pop-up that updates dynamically depending on which station you press. So stepping back to where we started, we've now got a much cleaner visual and standard labeling format. 2, we've got calculation on the fly for our symbology and returning something within our pop-ups. We've also got a pop-up that pulls in information that's not actually available to our users. And before I hand back to Liv really quickly, I want to just touch on a little bit of the art of the possible. So earlier in that little demo, we saw that we've actually got some charts in our pop-up. So how did we do that? We did that using an arcade block, which I mentioned earlier, and we can have a little look at what's actually going on. So it's not too dissimilar to what we've been looking at. We're going to pull in our data set, in this case, all of the related records that exist. So it's really hard to actually draw insight out of those because we can't symbolize by them. This is a good way to bring them in. So we're going to fail fast again, really early. And then from then on, we're going to construct our single instance data structure that drives that chart. So you notice I've got a few console calls throughout the script, and those are really handy for getting a look at what's actually going on as it executes. So if I run, we can talk through what's going on using that console. So first of all, we've set up a days of the week array, so that all looks good. We've pasted that in the first line. And then what we want to do eventually is get to the stage where we've got two arrays, one that sums up the total number of people moving through a station, and then secondly, the total number of days that exists. So that's going to give us our daily crowding for each day of the week. To do that, we first have to start with some empty arrays. So that's what we're doing on lines 32 to 39. We're starting them empty at first, and this for loop over here is just pushing zeros into it so we can populate it later on. And that's what this console call is telling us. Next, we're going to use a for loop to calculate those people and those days moving through. So this is what this for loop, line 45, is doing. I'm going to push those in, and I've used this console call to just confirm that those actually have data inside of them. All that's left to do now on line 58 is actually divide one by the other. And at the end, if we look at that console call down here, we get that dictionary with key value pairs for Monday, average crowding, and so forth. And that's what's going to drive our chart, which we return on line 75. So we can feed in our ordered days and our attributes. And to get that nicely formatted dictionary, we use the suggestion tab. So there's some really helpful stuff in here under the templates. If you come to the chart option, you can just pop that straight into your code and populate it. And that's it from me. I'll hand back over to Liv.
Thank you, Matteo. So now let's take a look at some advanced formatting options in ArcGIS Experience Builder, which is available in ArcGIS Online and ArcGIS Enterprise from version 12.0 onwards. So what can we do with Arcade? The first thing we can use is advanced dynamic content, and this involves running calculations on your data and returning dynamic values that can be used in your widgets, such as dynamically calculating button labels or your image source links. Secondly, we can use advanced dynamic styling. This allows widget background, borders, and other visual elements to update based upon your data, and this is available in the text, button, and list widgets. And the final use of Arcade is the ability to define your own custom dataset, which provides flexibility in the data which sits behind your widgets. So let's start here and take a look at this in action. So here we are in the Experience Builder app that I showed earlier, highlighting attractions located near London stations. Now, the points of interest dataset that I've got is extremely large, and I'm only interested in a specific subset of attractions. So rather than adding the entire dataset, I'm going to define my own. So if I go to Data, and then open up the Arcade editor, we can see what I've written. Hopefully this is now familiar to you, and the Arcade Assistant is available in Experience Builder too. So let's start at the beginning of my script on line 2, where I'm defining my feature set using the feature set by portal item function. This is a really powerful function because it allows us to access any layer that we have permission to view in our portal, instead of just relying on layers that were in our map. We can then define the portal URL, the layer and item IDs, and on line 6, we can define the fields we want to include. As we're keeping performance in mind, we're only returning the fields that we need. Then, on line 10, I'm defining a SQL-style filter expression using an in clause to specify which categories I want to include. Only the description values that match what I've specified in the script will be returned. And finally, we simply apply that filter query to our original feature set using the filter function. Now, if I go ahead and click Run, we can see a preview of our custom data source. Now, you can see that only the fields specified are returned, and you may notice that some of the URL values are null, and we'll come back to this shortly. So this data source can now be used to underpin any widget within our experience. And that is exactly what we've done. We've used this data source to underpin this filter widget, and below it we've added a text widget to give us dynamic feedback on the filtering status. We can apply Arcade in the text widget by clicking the Arcade icon next to dynamic content. So this expression is designed to respond to any filters that we apply within our app. And the first thing that we need to do on line 2 is go and find our data source. And as Matteo showed earlier, we can find this in the profile variables. In this case, it's data source _1. This ensures that the data we're using in the expression is what's being used elsewhere within the app. Then, on line 5, we read the current where clause applied to the dataset, and this reflects any filters that have been applied. Then, on line 8, we simply check whether a filter is currently applied or not, and then based on that filter result, the expression counts the number of records meeting the current criteria and returns a message stating the number of records that are currently displayed. Finally, on line 18, simply, if no filter is applied, we're returning a default message stating that all records are visible. Now let's have a look at this in action. So if we go ahead and enable our filter and filter to art galleries, we can see we now have an active filter with 365 records that are displayed. Now let's have another look at dynamic content in a different place. As I mentioned earlier, not all points of interest features have a valid web link, and we want to ensure that these buttons always have a valid data link behind them. So if we click on our buttons, click Set Link, ensure that link to is set to URL, then Arcade will be available in the drop-down. We can add logic here to define what should happen if a URL is missing. And this is a super simple expression that just states, if the URL field is null, then we're returning an alternative link so the user can still find out more about this attraction. If you are applying Arcade to lists, please make sure that the list itself and any widgets within it, in this case the button, are connected to data. So this will allow you to use Arcade here. And finally, I wanted to show an example of dynamic styling, using a script that Matteo showed earlier in a different context. We want to change the list item background color dependent upon the attraction type. So if we go ahead and select our list, expand states, and click the cog next to dynamic style, we can open up the Arcade editor. Hopefully the when statement you now see here is familiar, where we're defining the hex code color that we want to return for each of our descriptions. This time, we've just applied this logic to the background color on lines 2 to 4. If you are applying styling in this way, please do remember to apply it to alternative states as well, such as hover and selected. Now, before I hand over to Matteo to talk us through ArcGIS dashboards, I wanted to highlight that this dashboard has actually been embedded within this experience builder the whole time. And this hasn't impacted our performance at all because we've chosen to use views navigation and section widgets instead of pages and views. And this is because this allows us to make the most of the lazy loading functionality that's available in Experience Builder. This is a really effective technique because it prevents all your content from loading up front and only loads content when it's actually needed. So with that, I'll hand back over to Matteo to talk us through Arcade in dashboards.
Thanks very much, Liv. And I'll keep it quite brief, but what I want to mention is that in the slides earlier, we flashed up the fact that Arcade can be applied in data expressions, same as in Experience Builder, but also across lists, tables, and indicators. So I'll really quickly give you an example of how you get to that Arcade initially, and we'll talk through a list after that. So here I am in my dashboard, and if I were to add, for example, an indicator, select a data source. Once I've selected that, there's this indicator option in the menu, and you'll see there's this option for advanced formatting. Once I enable that, we'll get that familiar builder come up again. And the one key difference to note between the map viewer and dashboards is the fact that that dictionary, so from line 3, is ready populated for you to essentially know what you're going to return. So keep that in mind if you're doing so. And let's take a little look at our list widget. because what I really want to focus on is the fact that Arcade is really powerful for creating single instance data structures that allow you to summarize statistics that aren't immediately available. So over here, you'll see I've got like network level statistics for accessibility, number of stations, busyness. Now, if I were to add in a default list for my stations, it might look something like this. And we can make that look a little bit more snazzy, like we've done over here. But we can't get any further insight about group level statistics. But we can use data expressions to define our own groups. So if I head into my settings, under my data, I'll show you what that looks like. So Liv's just showed us this expression on line 2, feature set by portal item, and we're just going to pull in our stations there again. And then all we're doing is applying 2 functions. So first of all, group by. And what this is doing is taking 3 arguments. First of all, our feature set, the attribute that we want to calculate statistics by, in this case our network. And then line 15 onward, we're constructing what's called an object literal. And this is what allows us to calculate that data structure that we're going to use. So first of all, we'll give our fields a name, like total stations. And our statistic in this case is going to be a count of each name. We can also make use of SQL 92 expressions. So on line 17, we're using a case when function to sum up how many stations have the tag not accessible. And we're just going to sum that using a sum statistic. And on line 18, 19, like we've done many times already, is we're calculating crowding statistics using averages. Then we're going to wrap all of that in an order by function, and that's just personal preference. I want the network with most stations up top. But if we run that, we get a nice preview of what's actually driving that list widget now. And once I've got that sorted, I can then come to my list option like we did before, and I've got my advanced formatting enabled. And I want you to think about this a little bit like we did with the map viewer. So when we're defining a pop-up, we've got attribute expressions, and then we can bring them into our template later on. It's the same exact thing going on over here. The only difference is that we're returning each of our attribute expressions at the same time. So if we were to break this up like we did earlier, for example, in the map viewer, we've got some calculations that do statistics for accessibility percentages, and we're going to leave that. We're not doing anything else with that now. We're going to use another when function to calculate some colors that we can apply to our template. And then we're just going to do the same thing again in terms of calculating crowding statistics and returning a nice user-friendly sentence to give a numeric idea about what's actually going on. And then, like I said, return all of those within your dictionary, and they become available in your template. So for example, I can add this % difference sentence for the user. I can come into my expression list. This is like you'd add any normal attribute, but we can now add in our calculated expressions. The one key difference here with the map viewer is the fact that to change the color of our text, so for example, over here, we have to come into the source HTML. So templates are driven by HTML, so we just need to make sure we find the right text, come into its style tag, and define its color like we've done over here. Oh, sorry, over here. There you go. It's still possible, but just be aware that that is a difference. And with that, I'll hand back to Liv.
Thank you, Matteo. Now, before wrapping up, and I'm conscious I'm standing between everyone and their lunch, I wanted to briefly touch on how to optimize your map and app performance. As the ArcGIS system continues to grow and offer more capability and functionality, we want to make sure that this never comes at a cost for your end user experience. Between Matteo and I, we've already highlighted a number of performance-focused tips and tricks for your arcade and for your apps, but I wanted to touch on some decisions that are worth considering early on so that you can ensure that your apps have great performance over time. Now, this all starts with data design. The size and structure of your data directly impacts how quickly it can be queried, rendered, and displayed. One of the easiest wins is choosing the right layer type. Feature layers are often our default, but if your data is primarily for viewing, then tile layers can provide a faster alternative. Field design also matters more than people often realize. Where possible, do opt for integers instead of floating point numbers and reduce the number of decimal places where that level of precision isn't needed. Please do review your text fields too, as these can often default to large numbers of characters. And finally, please do ask the question, what is each field actually being used for? If it's only being used for pop-ups and symbology, please do consider calculating it dynamically using Arcade, like we've shown today. So once your data is designed, the layer settings play an important role in how ArcGIS can work with it. This all starts with editor tracking, which is extremely useful when needed, but if you do have it enabled and you're not using it, it does add extra fields and can cause your data set to grow quickly. Another important tool is indexes. Every time your symbology is rendered, a filter is applied, or a chart is generated, a query is sent to the underlying dataset. Without indexes, it scans the entire layer until it finds what it needs, and this can become inefficient as your dataset grows. By applying attribute indexes, you can locate and return your records more efficiently by narrowing the search to just those fields you rely on most. For those of you that have large, really heavy data sets, I recommend you also have a look into column store indexes too. Now, spatial indexes perform a similar role for geometry as attribute indexes do for data. They speed up your spatial queries, such as map extent checks and intersections. Also, if you do have layers with detailed geometry, such as lines and polygons with lots of vertices, do consider enabling optimized layer drawing to speed up the rendering. Please do note this does come with additional storage cost. And finally, for those of you today that have layers that are publicly shared, please do review and set an appropriate cache duration. ArcGIS Online uses something called the Content Delivery Network, or CDN, to cache common requests. This means the responses can be reused instead of regenerated, reducing load on your service. So if you have data that does not update very often, consider decreasing the frequency from the default of 30 seconds. It's all about managing your performance with how current your data needs to be. And finally, where all these decisions come together is the web map. And again, small choices can have a big impact. We've chosen to frame these points as questions on this slide to encourage you to reflect on your own map design choices. And I'll touch on a few of these. The first is something fundamental, of ensuring that your data and maps are using the same projection, as reprojecting on the fly does cause unnecessary processing. Secondly, please do make use of aggregation, visibility ranges, and other filtering techniques to ensure that your data is only drawn at scales where it adds value. And finally, just a note on custom symbology and visual effects, and a reminder here to just be deliberate. Complex and multi-layered symbols can be expensive to render. So if you're going down this route, just consider the best balance between visual impact and performance. Ultimately, these are not at all restrictions, but opportunities to make informed design decisions to ensure that your maps and apps always remain scalable, responsive, and enjoyable to use. By considering these decisions early on, you're setting yourself really strong foundations to make the most of all the functionality that you see here today, whilst also making sure that your users have an amazing experience. Now that's everything from me today, and I'll pass over to Matteo to wrap up.
Thanks, Liv. Brilliant. I won't keep you much longer because I know lunch is on the way, but I hope you can see throughout the session how you can make your maps much clearer and more usable and make that user experience a long-term feature of your organization. So the good news is there are a lot of resources out there to help you get started with all of this stuff. So we've gone ahead and put some resources in a QR code for you to scan if you'd like to get started. And all that's left to say from us is thank you for listening. And we hope leveling up your maps and apps has become less of an arcade game and more of a reality. Thank you very much.